you guys can't see that. Okay. So when I build the unit circle, I'm starting with my 90-degree family, so I'm putting this one in pink. So in that 90 degrees, if I look at splitting this full circle into 90 degrees, I know two things about the full circle. In degrees, it is how many all the way around? 360. And in radians, 2 pi, because I know that the unit circle has a radius of what? 1. And I also know that because of the 1, 0 right there. So, a fourth of that circle, or 1/4 of 360, is what? 90 degrees, so we'll go through and do the degrees first. 90 degrees, what is this? 180, 270. So think about this in terms of 9 times 1, 9 times 2, 9 times 3, if you're having trouble remembering the degrees. 90 times 1, 90 times 2, 90 times 3. So, then I'm going to do my 45. Oh, no, I didn't do my radians yet. First we're going to do the radians. So, if I have a full circle of 2 pi, half of that is what? Pi, or 1 pi. And if I start looking at this top half as just 1 pi, then the fractions become a lot easier to deal with. So, if I have my 1 pi for the top half, then what am I for the 90 degrees? 1/2 pi, or pi over 2. And you can write that either way, 1/2 pi or pi over 2, whichever you remember. Once you figure that part out, then it's pretty simple. So 0 pi over 2, 1 pi over 2, 2 pi over 2, because 2 over 2 is just going to give me 1, and then 3 pi over 2. Your 90-degree family is also going to be part of your 45-degree family, because 45 is exactly half of 90. So I'm going to do that one in yellow. So, if my 90 degrees was 1/2 pi, then 40 to 45 degrees is what? Quarter. So 1/4. So this is going to be pi over 4, or 1/4 pi, 2/4 pi, 3/4 pi, or 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. And I kind of jumped to the radians, so I also need to do the degrees. So we've got 45. Ivan, would you close the door for me, please? 45, 90, 135, 180, 225, 270, and 315. Next, I'm going to put my 60-degree set in blue. So if I just look at my blue lines here, that cut the top of my circle into how many equal parts? 3. So 1, 2, 3. So my radian measure here is going to be 1/3 pi, or pi over 3. So we've got 1 pi over 3, 2 pi over 3. The 180 is going to be a part of that. So 3 pi over 3. Down here, 4 pi over 3. 5 pi over 3. I'm going to run out of room for that. And 6 pi over 3, which would reduce to 2 pi. My degrees for that, 60, 120, 180, 240, 300. Questions on that family? Finally, we're going to have the 30-degree set. I'm putting that one in orange. So, on my 30-degree set, the 60s and the 90s are also going to be a part of this because they're divisible by 30 as well. So, I have my 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and 330. And if I just look at the top half of my circle again, 30 out of 180 is a fraction of 1/6. So this breaks it into 1, 2, 3, 4, 5, 6 equal parts. So this is pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. That one's 5 pi over 6. It's pointed to the wrong one. 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. So understanding how the fractions of the circle work is going to be, to me, a little easier in memorizing the degrees and radians here. In terms of your cosine and your sine, I'm going to bring you back to what we did last week. So I have here, take that down, I'll put that back up, so if you didn't get it all, don't worry. I have a 30, 60, 90 triangle. And what we worked on last week, we know that this has a hypotenuse of 1. 30, 60, 90 triangle is half of a equilateral triangle, which means this side over here is 1/2. And then we used the Pythagorean theorem to find the third side, which ended up as a rationalized answer being 3 pi over 2. So, just reviewing what we did, we took those and lined them up to try to find our x and y coordinates. So if that 30, 60, 90 triangle fits there, that means our x value, we're going over rad 3 over 2, and we're going up 1/2. What we also discovered has to do with how those relate to sine and cosine, or what you should have discovered. If you didn't, you didn't. And if we think about this in terms of sine, how do you calculate the sine? Sine of theta equals what? Opposite over hypotenuse. So the opposite side, 1/2, divided by 1, which is just 1/2. That happens to be your y value. The cosine is the adjacent over the hypotenuse. So in this particular case, rad 3 over 2 divided by 1, which is also just rad 3 over 2. So the cosine of that angle is your x value. Cos x, sine y. Remember that a little bit dirty, and it'll probably stick in your head. And that also, the other thing the other reason that works is because when we're finding the height of all these, when we go around the circle, the sine graph was that vertical distance we were looking at, and the cosine graph was the horizontal distance that we were looking at. And we'll review that part again later. So with our 45-degree triangle, 45, 45, 90, we use the Pythagorean theorem to figure out that both sides, non-hypotenuse sides, were rad 2 over 2. So both my x and my y value for the 45 are rad 2 over 2. And then I don't have my 60-degree triangle, but I'm going to flop my 30-degree triangle over, and that one fits right there, with that side being 1/2 for my x value and rad 3 over 2 for my y value this time. Once you figure that out, you don't have to continue to figure anything else out, because what happens to our coordinates? What changes on them? Negatives, where the negatives are. So, if we look at our 60-degree family here, all those coordinates are going to be some kind of form of 1/2 and rad 3 over 2. We just have to pay attention to the negatives. So over here, which one is negative? X value. So we've got negative 1/2 and still positive rad 3 over 2. Down here, what are we doing with the negatives? Both negatives. So negative 1/2 and negative rad 3 over 2. All jumbled there. Over here, what's going to be negative, x or y? Just y. So I'm going to have 1/2 and rad 3 over 2. 45, all are going to be some version of rad 2 over 2, rad 2 over 2. Just watch the negatives. So negative rad 2 over 2, positive rad 2 over 2, negative rad 2 over 2, negative rad 2 over 2, positive rad 2 over 2, and negative rad 2 over 2. And then if I look at my 30-degree family, same thing, rad 3 over 2 and 1/2, but now I've got negative rad 3 over 2 and 1/2, negative, negative, over here, positive, negative. So that is my completed unit circle. And just to be very clear again, this quadrant from 0 to 90 degrees, you need to know degrees, radians, cosine, and sine. That's why I'm continuing to have you do that for the warm-up. Trying to do it by memory. But that's minimum proficiency is just that first quadrant. Highly proficient is the full circle. And if you know the pattern, the full circle isn't much harder than the first quadrant.